body, a pain signal has been fired off and is being transmitted across the synaptic cleft at a regular frequency. But when these neurons are under the influence of opioids, the transmission of pain signals is severely diminished. Over time, an interesting phenomenon occurs. The neurons re-establish the strength of the transmission. This is referred to as opioid tolerance. A closer examination of the neuroplasma membrane might give us better insight into one of the mechanisms involved in this phenomenon. Upon binding of the opioid ligand with its receptor, a cascade of biochemical events are set off, which collectively induce the overall suppression of the neuron's ability to transmit signals. However, within minutes of the receptor's activation by the opioid ligand, the entire receptor complex is internalized into the cell. Under normal conditions, most of the internalized receptors are recycled back to the cell surface, while some are degraded through a complex biochemical process. And thus, a delicate equilibrium exists between the recycling of the internalized receptors and their degradation. During the development of opioid tolerance, there seems to be the reversal of this trend, so that more receptors are degraded than recycled. This phenomenon is known as receptor downregulation. As a result, fewer receptors are available on the cell surface for the opioids to bind. Consequently, more opioids are needed to induce the same level of signal inhibition during pain processing. Therefore, it appears that receptor downregulation may be one of the underlying causes of opioid tolerance, and further research is required to evaluate this hypothesis.